doing, we're going to use series to approximate the definite integral to the accuracy of less than 10 to the power of negative 8. So let's go ahead and first find a series representation for our f of x equals 1 plus x to the power of negative 1/2. So to do that, and then we're going to substitute for x cubed. So first, let's try, where n equals 0. So we're going to have f of 0, and this is going to be 1 plus x to the power of negative 1/2, and we're evaluating this at x equals 0, and that's going to equal 1. All right, now for n equal 1, we're going to do f, the first derivative at 0, and that's going to give us negative 1/2 times 1 plus x to the power of negative 3/2. And if we evaluate this at x equals 0, that's going to give me negative 1/2. Let's crank out some more. Let's try n equals 2. That's going to be the second derivative at 0, which equals 3/4 times 1 plus x to the power of negative 5/2. Evaluated at x equals 0, that's going to give me 3/4. And try one more. Let's see. Let's do n equals 3. So the third derivative at 0 is going to be negative 15/8 times 1 plus 8 to the power of negative 7 divided by 2. And at x equals 0, this is going to be negative 15/8. All right, so our series is going to end up being 1 minus x divided by 2 plus 3/4 times x squared divided by 2 factorial minus 15 divided by 8 times x cubed divided by 3 factorial plus ... And that's for this, but we actually have x cubed. So if you put in the x cubed, it's going to be, and if I can squeeze it in here, let's see if I can. I'll put it right in here if I can, and then I'll rewrite it. So if we do this 1 divided by square root of 1 plus x cubed, this is going to be 1 minus 1/2, and now it's going to be x squared, and then, or cubed, sorry, plus 3/8 x to the power of 6, and then minus 5 divided by 16 times x to the power of 9. All right, now that we have that, we can evaluate this, and I'll rewrite this so you can see it better. We want the integral from 0 to 0.1 of derivative of x with respect to 1 plus x cubed, which equals the integral from 0 to 0.1 of 1 minus 1/2 x cubed plus 3/8 x to the power of 6 minus 5 divided by 16 x to the power of 9. All right, dx. So when you do that, you're going to get this equals x minus 1/8 x to the 4th plus 3 divided by 56 x to the 7th minus 1 divided by 32 times x to the 10th plus ... and then we're evaluating from 0 to 0.1. So the 0 part here is not going to matter since they all have x's in them. So by the alternating series theorem, we're going to have 0.1 minus 1/8 times 1 to the fourth is going to be our answer, since if you have 3 divided by 56 times 0.1 to the seventh, this is approximately 0.000000, and then we have 0.0054, which is less than 10 to the negative eighth power. So since this is less than, our result is going to end up being what this is, which is going to be 0, I have it in my calculator, 0.099. Then we have 987 and 50. So that is your answer, your desired result. Thank you. Have a nice day. Bye-bye.